In this video, I will introduce the basic concepts of case control study design. Similar to a cohort study, in a case control study, we're asking whether a particular exposure is related to a particular disease or other health outcome. One difference, though, is that in a case control study, we start by grouping people based on whether or not they have the outcome rather than whether or not they have the exposure. For example, say we want to know if smoking cigarettes is associated with lung cancer. We find a group of people that has lung cancer. These are our cases. Then we find a group of people without lung cancer. These are our controls. We then ask everyone in the study whether or not they have a history of smoking, which is our exposure. The general idea is that if more people with lung cancer have a history of smoking than people without lung cancer, we say there's an association between smoking and lung cancer. In this example, 4 out of 7 of those with lung cancer have a history of smoking, compared to 1 out of 8 of those without lung cancer. Now let's talk about common sources of bias in case control studies. First, let's talk about confounding bias. Just like with cohort studies, case control studies are observational. This means that we're simply grouping people based on whether or not they have the outcome we're interested in. There's no allocation to case or control status, and therefore we cannot randomize. It would almost always be unethical to assign people to case status, such as lung cancer. There are 2 common procedures for reducing confounding bias in case control studies. The first, like cohort studies, is statistical adjustment, which is briefly described in another video. The second is matching. The basic concept of matching is that we make our case and control group equal on potentially confounding variables. Say, for example, we're worried that age might confound the relationship between our outcome and our exposure. When we recruit a case into the study, we take a look at their age. Then we find a control, someone without the disease outcome, who is the same age as our case. We repeat this process for everyone in the study. At the end, we have a case sample and a control sample that's equal on age, which allows us to rule out age as a potential confounder of any differences in exposure that we see between our outcome groups. Researchers often match on more than one potentially confounding variable. For example, we might match on age and gender. If we found a case who was 65 years old and male, we would need to find a control or somebody without the disease that is also 65 years old and male. Researchers can match on as many variables as they want. However, the more variables you try to match on, the more difficult it can be to find controls that match your cases. A second potentially important source of bias is selection bias. Say, for example, that we identified lung cancer patients through a cancer hospital. Then we selected controls from the general community. It's possible that our cases were more likely to smoke because they were selected from the hospital, and people in hospitals generally tend to be less healthy than people in the general community. So it may not be the lung cancer that is associated with smoking, it may be hospital patient status. Selection bias is most often combated by carefully designing the study's sampling procedures. When at all possible, cases and controls should be drawn from the same underlying population, and both cases and controls in the study sample should be representative of cases and controls in the underlying population. A third common type of bias in case control studies is recall bias, which is a type of information or measurement bias. It's often true for case control studies, like in our example, that participants are asked to recall the extent of their exposure to the exposure variable of interest. For example, participants are asked to recall their history of smoking. Recall error is a very common source of measurement error when people are asked to recall previous behaviors or experiences in a research study. People do not have perfect memories, and therefore often misreport their past experiences. If recall error is unequal between cases and controls, this recall error could bias study findings. Recall bias is combated as much as possible by careful measurement of the exposure variable. For example, a researcher may be able to corroborate a participant's experiences with a participant's family or friends. Skilled interviewers can also use memory cues to help participants accurately remember whether or not certain events or behaviors happened during a particular period of time. Finally, case control studies are susceptible to misclassification bias if misclassification happens for either the outcome or exposure status. In case control studies, misclassification bias may arise directly from recall bias if there is error in participants' recall of previous experiences. Like in other study designs, and with other forms of information bias, misclassification bias can be minimized by carefully designing and implementing measures of the outcome and exposure status.